Okay, yes. Move that away. So yeah, cosine rule, you will usually be asked to get the length of a side, but you can be asked to get the side of an angle. You must manipulate nicely. Area rule, it is straighten forward the area, but sometimes you could be given the area and maybe one side and the angle. Then you must calculate the side here, then you must manipulate. That is how the questions can vary, and you must know which one you can use, which one which one what that like that'll make your life easier, right? When you're calculating, because sometimes it won't be this simple and straightforward. And I will send a question in the group later on or tomorrow to this evening when we are done. It's quite a nice tricky one to do, just for extra practice. But this calculations is always very straightforward, and always when you're asked to do area, you will use the cosine rule with it. That's why they are going together now. Sometimes, not always, but most of the time, you will use the cosine rule and the area rule. Okay, so let's begin. So, looking at our triangle first, the first question is to get the length of RT. So, what does the cosine rule say? The cosine rule says for the length of a side, let's use a green pen. So, to calculate the length of a side that I don't have, I need a length of a side that I do have, two lengths. So I need one length and another length, and the angle that's between those two lengths that I have. All right. So I need a length. Let's say this is our 6 meters, and then I also need another length. That's my 5 meters. Then between those, I need their angle. I need their angle with the cosine rule to get this length over here. Alright, so I need a side, angle, and a side. Side, angle, side with the cosine rule. But let's put it in the letters we have, alright? So this is a capital S, capital T, and a capital R. So directly opposite this R, we have our small r. Directly opposite this R, we have our small r. So the side, the name of this length here, we can either call it ST, but we're going to call it small r. So the next one will be opposite T, which is going to be our small t. Opposite S, our angle S, will be small s. All right. So our formula will look like this. So the length of RT, instead of saying RT, we're going to say S squared equals R squared plus T squared minus 2 RT cos. So this angle's name now is angle S. So angle S, like that. Then all I have to do is substitute in, because I have all my sides that I need and my angle. I have my angle, I have my side, angle, side. Alright? So I substitute my r, my small r, which is 5 squared plus 6 squared minus 2 times 5 times 6 times cos of angle 40 degrees. Then I will get in my calculator. All I do is into my calculator directly. So it is 2 times 5 times 6 times cos of 40 degrees. Right? All of these together. Then I will get 15,037. Then I want S, right? I want the length of S, not S squared. So all I do is I square root. Then my S is equal to 3,878 meters. Because my lengths were given in meters, my answer will be in meters as well. So there I have now the length of S. So I can even put it in and say this is now 3,878. Straightforward, right? Side, angle, side. Side, angle, side is all you need for the cosine rule. So the next question is to calculate angle R. So because we have knowledge of our sine rule, right? And our sine rule is saying sine rule is saying sine of the angle over a side equals to sine of an angle that I don't have over a side that I do have. Then I can manipulate to get that angle, right? So what I mean is we're gonna say sin 40 degrees over this side there that I just got, 3,878 equals to sine of this R here, sine angle R, sine angle R over 5. That is sine rule, right? I had to look at my drawing, I had to look at my triangle, and I had to think, what formula do I know? Or what rule do I know more? Yeah, what rule do I know that will get me my angle R with all the given information that I have, all the given and calculated information that I have? And it's only a simple answer. It's sine rule. You can't do anything else. Straightforward sine rule. All I do now is I cross multiply. When I cross multiply, it's going to be 3,878 sine R equal to 5 sin 40 degrees. Then to get my sine R, I divide and then to get my R, to get my angle R, I say sine second function. This whole equation over here is 5 times sin 40 over 3,878. Like that. Then all I do, I put it into my calculator. And then my angle R is 55,976 degrees. Straightforward. Straightforward. For my cosine rule, I use side angle side to calculate this length here. So always it will be the same. You will calculate the length that's opposite to the angle that you have. You need that angle to calculate the length of the side you don't have. The side you are looking for, the angle will be given always. And the angle will always be opposite to the side you are looking for. The next question would be, let's just say they asked it like this now. They asked for the length of RT then you think, okay, can I use the sine rule? Let's say you didn't get this one yet. Can you use the sine rule here? Can you use it? Sine 40 over s equals to, no, you can't. Because for the sine rule, you need at least two angles in this triangle to get all the sides. And you don't have two angles, you only have one angle. So you can't say sin 40 degrees over this s here equals to sin r over 5. You can't say that because that's two unknowns. You at least need one that is unknown to get the answer. You can't have two unknowns, then you can't get anywhere, right? So yeah, let's look at it. Then you say, okay, based on the formulas I have and the rules I know, what formulas can I use to calculate my answer? Then you see, you must first notice I have a side, angle, and a side. Side, angle, side must be cosine rule. It's the only rule that will work like that to give me a side, right? So a hint would be you're only ever gonna use the sine rule once for a calculation that's simple like this. A simple triangle like this, you will only use the cosine rule once. So if they ask you for angle R in the same question like they have now, if you don't have the area yet and you can't manipulate the area rule in any way, the only thing you can use is the sine rule. You must be able to identify the questions like this and what you can use, what you can't use based on what you have been given and what you calculated. That's why it's good to know your formulas. Okay, everybody's happy? Go to the next one. Is anyone not happy? Okay, so let me get a piece of paper. So if you look at our triangle, our triangle is this here. S T R 6 meters, 5 meters, 3.878 meters. And now we need angle R. Remember I said now, you will only use cosine rule once. You will only use cosine rule once. Okay, we have a squared. Let's use the formula we wrote down. So the formula we wrote down was s squared equals to r squared plus t squared cos of angle s. This is our cosine. For sine rule, we have sine angle r over small r, sine s over small s, sin t over small t. For area of, let us say, if we're looking for this one, so it's gonna be this and this. So small t and s sin r. So, looking at this, do it like this rather. Looking at this, to calculate angle R, must look at the formulas we have. So, angle R, we might be able to use the cosine rule to manipulate at least. We're not going to get any side because we have all the sides, but we can most likely manipulate the cosine rule, a version of the cosine rule, to get our angle R. And it's going to look like this then. So R squared. So to get this R, because remember, here's my small r, there's my small t, and there's my small s. So I can get my small r equals to t squared plus s squared minus 2t is um, cos angle r. Alright? So I have a side, I don't have my angle, and I have my side. Remember I said that you can manipulate based on what you have, you can manipulate to get the angle. So I have the side, I have this side, but I don't have the angle. So what I can do here is manipulate to get my R alone. Then you will get the exact same answer. You should get the exact same answer. We can try it out now actually. So yeah, sometimes it's gonna be like that, but to manipulate this, it's gonna be a lot of work. Or you can just use the sine rule. Because for sine rule, um, you need at least one unknown and the rest known. So I have my side R, I have my side R. I don't have this one. I have my side, I have my angle S, and I have my side S, my small s. I have that one. I have my sine T. I don't have sine T, so I can't use this one. But for sine rule, I only need two, like this. So I can get it, I can get my unknown much more simpler than I can get this one. But I can do this as well, but it'll be more work. You'll get the same answer. You can test it out if you want. Um, let's do it quickly as possible, just so you guys can see if you ever need to manipulate. So r squared equals to t squared plus s squared minus 2t s cos r, like that. So my first step, the first thing I would do is take over, so r squared minus t squared minus s squared equals to negative 2ts cos r, like that. Then I would say r squared minus t squared minus s squared over negative 2ts cos r. So the next thing I would do is cos second function r squared minus t squared minus s squared. Am I still with you guys, or are you still with me? So my r squared is 5. Nicely, 5 squared. So my r is a 5, right? My r is a 5 minus my t, small t, is a 6 squared, minus my s, which is 3,878 squared. r, okay, it's like that. -2 small t is 6 s, which is 3,878. And if I put in a calculator, I hope to get the same answer. Otherwise, my brain is gonna break now. So cos second function 5 squared minus 6 squared minus 3,878 squared minus 2 times 6 times 3,878. And my answer I get here is 55,976 degrees. And what answer did we get on the other page?
It's the same answer, sir.
Yeah. So you see why you would rather use the sine rule than this one? Because you can easily make a mistake here with a decimal or the sign, but you can do it this way. It's just the sine rule is much simpler.
I see, sir.
Okay, shall we continue?
Yes, sir.
Let us do it. Okay, so the next one. Next one is asking us for the size of angle P. So again, identify what you have. Sometimes they won't say use the cosine rule to calculate this, to calculate that. They won't say use the sine rule. Maybe if you're lucky they do. But they normally won't ask you. You must know which rule to apply. So looking at this, we don't have any angle. We only have sides. Based on what I know, to get a side, to get the angle, I can't use sine rule because for sine rule I at least need one unknown and three knowns. All right. So what do I do? What do I do? Only thing I can use is the cosine rule. All right. Because for the cosine rule, I need a side and a side. I need a side and a side. Then between those sides, I need an angle. So side, angle, side. I have the two sides, which means I can get the angle if I manipulate. All right. So let's do that. I must first get my symbols correctly. So this is capital P, capital Q, capital R. Directly opposite angle R is my small r. Directly opposite angle P is my small p. Directly opposite angle Q is my small q. So what do I do? Oh, I'm looking for angle P. For angle P, but it's the exact same thing. Angle P, I need a side, angle, side. I have the two sides, so I just need the angle. But you can even practice by yourself to get the other angles using the cosine rule. It's just extra practice for yourself. So what do we do for angle P? For angle P, I must use the side. I must start with the side that is directly opposite it. So what I mean by that is the side you start with is the angle you end with in your formula, right? So the side you start with is the angle you end with. So they go together, right? So if you're looking for angle A, you must start with side A. So you can manipulate to get your angle A alone. If you're looking for angle C, you must start with C squared. Then you end with cos C. the cos of angle C. The same with B. If you're looking for angle B, you must start with B squared. So for angle P, we must start with the side that's directly opposite it. Alright? So we're gonna say P squared equals to R squared plus Q squared minus 2RQ times cos of angle P. And all I do is I manipulate exact same way I just did. For space, I'm gonna do it like this. To RQ. And then a space to now substitute. But you guys can check for the calculator also how much we're getting. I did it already, so I know the answer. But can someone tell me? So I know you're working with me. Should I pick somebody? Can someone tell me the answer? Anybody?
Yeah, so give me an answer.
Okay, let's do it. Is everybody still with me on this? 120. Lovely stuff. Correct. Nicely done. Is everybody still with me on this? Is anyone not with me? Not with us. We should be moving together. Okay. If no one is not with us, that means everyone is with us. Hello? You see, you need to substitute in your values here in a calculator. And then the calculator gets the answer for you. Is that your question? Remember, we had to manipulate to get angle P alone. And the only way to do that is to take these over, divide with negative 2RQ, then you do the inverse function of cos to get your angle P. But you need to substitute in your values. I just didn't have space here. Remember the second function cos, very important. Very, very important. Do you understand? Super mandla. Okay, lovely stuff. Okay. Um, Now we need the next one. Introducing the area rule. You'll notice it's the same triangles. This is just building now slowly. So, area. We need the area of this triangle. What does the formula say? So, the formula is saying the same thing, kind of, eh? area of AC, the area equals to half of a side times a side times an angle, right? Well, let's put our formula down in a way we understand it nicely. So again, I need a side angle side. I need a side, I need an angle, and I need a side. That is all I need for the area of a triangle. So for the area of this triangle, the area of triangle R is T. The formula is going to look like this. So half times, okay, firstly I need to get my my numbers, my letters, eh? Capital S, small s, opposite angle T is my small t, opposite angle R is my small r. Now, I need a side angle side for the area formula and the cosine area. Cosine rule, I mean. That is why they put together, right? Because you need a side angle side for cosine rule and area rule. So, for the area of this triangle, I need this side T, multiplied side R, multiplied sine of this angle here. So angle is. Notice it is not a cos here, it's a sine. Don't put a cos there now because you're used to the same thing now. Yes, it's similar, but area rule is with a sine, not a cos. Don't mix the two. So all I do now is I substitute in. Small t is 6, small r is 5, and then sine of 40 degrees. Then I put in my calculator, I make magic, and then my answer I get is 9,642 meters squared. Because meters, I mean area is in meters squared. First thing you must do, identify your side angle side. Very important. Identify your side angle side. Identify your side angle side. That's all you need. Identify your side angle side. Um, and let's just say and small letters uh, oh no, the name of the sides, because the name of this side, yes, you can name it RT, but you're naming it S, the same thing. Name your sides and identify your side angle side. That's all you need. Then you substitute the substitute. Yeah, substitute. Yeah, is that correct? Yeah. Then you substitute. Yeah, there is another area calculation that we can do, but we don't need it. Sometimes I don't think you'll ever need it, but I'll show you it. Is everybody happy here? Who is not happy here? Lovely. As long as we together. So the next one is asking for the area. Once again. And what did I say? For the area, we first identify um, a side, an angle, and a side. I didn't use um, PQR because there's no angle there. Identify your side, angle, side. All right. So, and then first thing you must do, identify your side, angle, side. Second thing, name your sides. So we do that now. Capital P, so the opposite angle P is a small p. Opposite angle R is my small r. Opposite angle Q is my small q. Then I substitute in my my sides. So doesn't matter which one I use, it doesn't matter. Area of triangle PQR equals to half. My side times my side times sine of my angle P. Alright? So yeah, I should have just did it nicely one time. So half 5 times 3 times sine of 120 degrees. And my answer is gonna be 6,495 meters squared. Straightforward, right? Is everybody okay with this? Because I want to introduce the other area calculation we have. I want someone to do it on the side here. Mhm. Okay. If nobody is stuck in.
Boss,
Yeah,
I have a question.
tell me.
What you tell me?
Hmm. I wonder if I mentioned that earlier. So if you look at this one again, it's the exact same thing all the time. You must look at your triangle and look what they are asking you. Look at what is given to you and what you've calculated so far. Then determine for yourself based on the formulas you know and the rules you know. What rules can you apply to calculate the missing thing they're asking for? Must you first calculate one side to get the angle? Must you first calculate the angle to get the side they are asking for? I can't tell you which one you must use. What I can tell you is identify what you have, what you've been given, what you've calculated. Then look at the formulas of the rules you know. Then you what do they call that now? You must eliminate the ones you can't use and the ones you can use. Like this over here. So for us to have gotten angle R that's here, I could have used my sine rule, right? Because I had angle S, I had side S, I had side R, I even had side T, but I didn't have angle T, right? I don't have angle T over here, so I couldn't use it. But for sine rule, I just need two. I need two, one whole set that is given, so I can use this this completed ratio to get angle T even, because I have three knowns and one unknown. But if I didn't have S, if I didn't have side S, and I didn't have angle T, I can't use these ratios. Like I can't use this ratio here and this ratio here because I have two unknowns. I at least need one that is unknown. I can't have more than one unknown in my formula to calculate um, the answer. So I could use these. I did use this example that I could use these two ratios here because I have one unknown, right? But I could also use this here because I have side R, which is 5. I have side R. I have side T. I have side S. I calculated side S. So I have these. So I could have gotten angle R by manipulating, and we did that. It's just more work. It's just more work. But I must always have at least one unknown in my calculation to get the answer of anything I'm ever given. It can be applied to anything. You at least need one unknown. Yeah. So you're just identifying what you have and the rules you have. All right. So nicely done. As long as you are winning. Yeah. Win. Yeah. No. No. Because why is that? Tell me, why is that? Why can't I use 7? I'm asking you now, Mo. You said which means you understood most. So why are you saying Oh, I see. Okay, no, no, I understand. So what is the first rule? The first step that I wrote down. Identify a side angle side. You will only deal with that side, that angle, and that side. So always look at where the side angle side is sitting. So here's my side, here's my angle, and there's my other side. So I will only use this side, and the angle that's between those two sides. You won't use, even if you have this angle here, you won't use that one. If you have the 7, but you won't use that 7 because it isn't within your side angle side. That's why you don't use it. Yeah, lekker. Okay. Side angle side. Even if you have any other angle side given, if you identify this side and this angle that's between those two sides, you only use them in your calculation. Don't mix anything. Okay? Lovely stuff. Lovely stuff. So we know this area rule now. A different area for us to use is, I think it's in your formula sheet as well, but it's looking like this. So So this is my first area rule. The second one that you can use if you really want to, you should get the same answer if you do use it. Um, but I recommend always only use what's comfortable to you and what's easiest to you at the time. At the time. So for my area rule, I don't know what this one is called, but in my formula, I have this. this isn't my area. This is just like, I don't know what this is. Let's say this is a constant of some kind. A constant, but a constant you calculate. Um, okay. Then for the area using this rule, it's looking like this. S S minus A, S minus B, S minus C. So looking like this. Then now to call this rule, it's a rule. So using our triangle we have here, we should now apply this rule. So I have my sides, and I'm gonna name my side. My sides names is R plus P plus Q over 2, right? And then just a quick answer. Their answer is gonna be 5 plus 7 plus 3 over 2. It is 7.5. 7.5. Then I must substitute in this 7.5 wherever I see a S. Sorry? Okay. So let's say this is let's call this our calculated constant. Alright? This S value. This S value is our calculated constant. Let's just give it a name. This remains my sides. So this is my R, this is my P, this is my Q. So it's gonna look like this. So S equals to S minus R, S minus P, S minus Q. This is my formula for my triangle, right? So all I do is now I substitute in my constant, my calculated constant, which is 7.5, 7.5 minus my R, which is 5, 7.5 minus my P, which is 7, 7.5 minus 3. Then I put into my calculator this, and I see what I get. So square root 7.5, open brackets, 7.5 minus 5, close brackets, open brackets, 7.5 minus 7, and then I say open brackets again, 7.5 minus 3, close brackets, equals to 6.495 meters squared. And what did I get? I got the same answer. You can use this rule if you're comfortable with it, and you can use the area rule we did this evening. You can do both. You can do the one to check the other one. You can do that, it's entirely up to you. A formula sheet. Let me see if I have a formula sheet. I do not. I don't see one nearby. But you can use it. Here's a formula sheet. Is it in here? Quadratic. No, it's not here. Yeah, most of these formulas is not given to you, and formulas you should know. But we have more than enough time to practice them, right? But yeah, this is our, let's say this is our S constant of our triangle. And every triangle is different, right? We all know this. every triangle is different, you will most likely never get the same triangle. So this is our S constant that we must calculate. Then we put this into our formula. We put our S into our formula. We substitute in our sides. We substitute in our values that we got. And then we get our area. Quite straightforward. Um, but yeah, we need to say side plus side plus side divided by 2 to get our S constant. If we substitute in our S constant in our sides, calculate the answer. Straightforward.
Sorry, sir.
Yes.
Can you still use that?
Good question. Very good question. Can you use this rule if you only have two sides? No, you cannot. You need all three sides to get your S constant. You need all three sides because you need to substitute in your sides over here as well. But you also need all three sides to get your S. You can't get your S without your all three sides. Good question. Thank you for asking. And yeah, as you can see, there's no angles involved. No angles involved, just sides. We can call this our sides constant. I don't know. Our sides variable. I don't know. Because you're using all the sides and it's the name is S. Maybe S for sides. I don't know. It's up to you. What you want to call it? S factor. I don't know. Give it a nice name. Are we together? Is anyone not with us so far? I don't want to move on and someone's not with us.
Please remove that page. I want to see the one.
Let me throw the page away. I will throw the page away for you, man. I can give you a few easy ones to do on your own. Yeah, I think I will do that. If everybody's happy with this, then I will send it now in the group, and then you guys can answer it between today and tomorrow, and then on Thursday we do the marking of the scope. Right? You can do that. Would they ask you the area and give you the sides without the angle? I wonder. So your question is this. So you have side A, you have side B, you have side C, and no angle. Yes, you're correct. Yes. Oh yeah, maybe. Because like they can ask you anything, to be honest. They can ask you anything in any way. There is most likely more than one way. Yeah, there's most likely more than one way to get the same answer. So to get the area, right, you need either a side angle and a side that is together, or you can use this rule we did now, or you can use this S constant um, with yeah all three sides. So let's say we're given this triangle, all three sides. We don't have an angle, so we can't use the area equals to half AB times angle C. So we can't use this one. But if we do the cosine rule on this triangle, we can get that angle C, then we can use this formula. If we're more comfortable using this formula, and if this formula is the only formula we know, and the cosine rule cosine rule formula. So I can do c squared equals to a squared plus b squared minus 2ab it's cos of angle C. Then I manipulate everything to get my angle C. Then I manipulate everything to get my angle C. Then I substitute my angle C into here. I can get my area because I have A and I have B. I have A and I have B and I have C. Here I have C, I have A, I have B. I have that A and I have that B. So I can get this angle C, put it in there, and get my area. I can do that, or I can just use this rule here. Yes. Yeah, it's just how you look at the question. That's why it's very important to know your formulas, know what you have, know what you can use. You can use either one, but use the one that's easiest for you. All right. Next question. Next question. Calculate uh, BC, the side BC. So to get side BC, what do we do? Cosine rule. We can't use sine rule because for sine rule we need at least two angles, two sides. We need a side, we need two angles and two sides. One angle that's opposite the side that's given, one and then another one that's the side opposite the angle. So um, first thing we do is we get our small letters, side A, C, and B. Then I'm looking for the length of BC, so it's gonna be A squared equals to B squared plus C squared minus 2BC times cos angle A. Remember, the side you start with is the angle you end with. And cosine rule is cos. You must use cos there. What I do now is I substitute in my numbers. 40 squared plus 30 squared minus 2 times 40 times 30 times cos angle, which is 35. A squared, A equals to 534,035. That's squared. And then A equals to 23,109 centimeters. Then the next thing for me to do is the area. So yeah, so my area equals to a side, which is side C times side B times my angle that's between the two sides. So side C is 30, side B is 40, sine 35. My area is equal to 344, 146 centimeters squared. Just substituting. Once you know the formulas, it's just substituting. Now, yeah, of course, we can use our new rule that we learned today. Just to do it, can even do it with me on your own if you remember it. So that's my triangle. First thing to do, I get my S constant, and that is equal to my side A plus my side B plus my side C divided by 2 equals to. Oh, I got my side A right. My side A was 23,109 centimeters. So um, this is more decimals, so you'll get a more accurate answer if you put all the decimals in. And I guess we can do that because why not? Yeah, let's do it now. Yeah, let's just do it so you guys can see nicely. 30 squared plus 40 squared minus 2 times 30 times 40 times cos of 35 square root. This is equal to 23,109 199.33 like that. So 23,109 plus b, that's 40, plus 30 divided by 2. So 30 plus 40 plus 30 over 2. That is 46, 5545997. But obviously we always round off to 46,555, 3 decimals. But because I want a more accurate answer, just because, not to show you, then what I do is I substitute that area, this area equals to square root s, s minus a, s minus b, s minus c equals to, my s value is a long number. I don't want to put it in nicely. But let's do it. 46, 555, 46, 555 minus a. A is 23,109, 46, 555, b which is 40, 46, 555 minus c, that's 30. Yeah. Yeah, it's a long number, it's a long mess, but let's see what we get. So my s value is there already, so I say square root my s value minus my long a value there, so 23,109 19933 close brackets, my s value minus 40 open brackets, s value minus 30. Answer. My answer I'm getting is 340, 1458618, and I always round off to 3 decimals. An area is in centimeters squared. And there you go. If I didn't include all the decimals, if I didn't include all those decimals, you would get maybe 343, 344 point what? 0.50, for example. You won't get this full answer as you're getting here. So that just shows you that Using this one or this one here, using this one here is more accurate, much more accurate than this one over here. Just to bear in mind, when you use this one, if you use this one, I would suggest you use the full decimals. You never know how far one decimal can take you. You'll go very far without all the decimals. You'll go quite far sometimes, depending on how lucky you are that day. But yeah, it's entirely up to you what you want to use. Is anyone not happy with what we have done today? I know it's still new, but is anyone not happy? Yeah, definitely you will see these applications in your test. Definitely. Yeah, determine the area. Yeah, yeah, you will need it, guys. You will need it.
Sorry, sir, just a question.
Yes. How much? Simple and easy. Oh, that's lovely to hear, man. Let me check for you and I'll tell you. Oh, only 2 marks. Wow. Only 2 marks. That just shows how simple it is. Yeah, guys, your test is very straightforward. Yeah. But this is cosine and area rule. This is cosine and area rule. Um, Side angle side. The most important identification you first need to do whenever doing area and cosine rule. Also, if remember I said they can ask you the question in any way. In any way. Sometimes they can give you a triangle. Sometimes they can just say the triangle. They can say, they can say, you have triangle with sides R is equal to 6 meters. Okay, let's say they say this. They can say this. They can say for you. They can say you have triangle. You have triangle. What is this? R is T. Triangle R is T. You have triangle R is T. Side R is equal to 6 meters. Um, Side ST equal to 5 meters. Angle is uh, uh, angle S equal to 40 degrees. They can give you this statement, then you must draw. You first draw. You say R is T. Then you put in between, okay, line RS is 6 meters. You put in 6 meters. Line ST is 5 meters. You put in 5 meters. Angle S is 40 degrees. You put in there 40 degrees. Now you calculate. Then you calculate from there whatever they ask you. But they can give you the statement of triangle RST has a side of RS that is 6 meters, ST that is 5 meters, angle S at 40 degrees. Then all you do, you draw the triangle, you put the labels, and you substitute in nicely. That's how you do it. You can be asked in any way. Be prepared for anything. Just think practically. Everything everything you're being asked, you've been taught, you've been shown, especially in the scope. Pay attention there. But yeah, very straightforward, guys. Side angle side is what you should be knowing. Knowing what rule to use when they ask you things like this, right? We spoke about this. Um, there's more than one way to solve a problem. That's mathematics. So just apply yourself nicely, man. You can do very well, guys. Very, very well. Really, you can. I hope everyone's happy. If anyone is not happy, let us talk now while we are still together. Speak now, forever hold your peace. I will send questions in the group, some questions that you can practice. I would say do one now and then do one tomorrow. And then I will give you a nice big one that you can struggle with. And yeah,
This is not right.